Okay, so hopefully you've downloaded the video for this one here. So this should be A3 here. We're on A-3. Okay, we're doing graphing simple exponential functions. So hopefully we got the A3 sheet. Here's our joke of the day, and I'll read it because it's kind of small. So if you're following, again, you can follow with lined paper, or if you've printed out, but this time you need graph paper. So be a bit tricky if you can't print it out. You'll need some graph paper. So let's read the joke of the day. Mark my words. You harness the negative power of yours, this negative power here, and you can make it to the top, just like me, just like x to the 3 here. So obviously this goes up, becomes x to the 3 if he harnesses that negative power. Okay, let's go on to the lesson, and hopefully you've printed it out. If not, you're going to need some graph paper today. Again, I want people to take pictures and then hand this in. Okay, so we're going to look at an exponential function, which pretty much is like an exponential graph, and it has an equation. So it looks like this, and we're going to be able to graph it. It's y equals a c to the x. Okay, examples are y equals 2, 3 to the x, and y equals 100, 0.5 to the x. Okay, the a, so this number at the front, this 2, and this 100, which is considered the a, okay, is one number, and then 3 and 0.5 is another number. The a itself is the initial value, so the 2 and the 100 is the initial value, okay, which is also considered the y-intercept when x equals 0. That's what the a is, okay? And c, the 3 and the 0.5, they're the multiplication factors. The 3 and the 0.5 are multiplication factors. Okay, let's just show you how the graphs look. So I will draw them over here. So I'll create like 2 grids. So maybe I'll just do a plain grid like that, and I'll do another one over here. Okay, so for growth, this is what happens. The graph starts here, and it like grows and goes up. Okay, the graphs go like that. It does go the other way as well, but sometimes we don't get into the negative numbers. For the decay, the opposite happens. The graphs come down like this. Okay, they start off high and they come down like that. So let's look at 2 examples. The decay usually has decimals and the growth doesn't. So let's show you one of each. So we're going to go over here. We're going to use a table of values to graph these. And I can tell you the first one here. Okay, this one's going to be growth. Okay, and the second one is going to be going downwards, going to be decay. So let's take a look if we can make it work. So first we're going to set up this first table of values. So this is what I do. So where the negative 3 is, you put it in the x. So you put 4, 2, and you put to the power of negative 3. Then you put 4 bracket 2 to the power of negative 2. 4 bracket 1. Oh, sorry, still 2. It still stays the same. 2 to the negative 1. You're just changing the exponent. 4, 2 to the power of 0. 4, 2 to the power of 1. 4, 2 to the power of 2. And let's keep going here. 4, 2 to the power of 3. Now, hopefully you have a good calculator, or you can find one on the computer. You can use your phone. Okay, and here's what I do. I do 4. So I'm going to turn this calculator on. So here we go. Clear it. 4. So the bracket means times 2. Then I have to find a power button. So my exponent button is there to the negative 3. So it's 4 times 2 to the negative 3. And I hit enter. And I get 0.5. So then over here, I type in 0.5. Then I go to the next one. Okay, I go 4 times 2 to the power of negative 2. Okay, in some calculators, you have to put the negative 2 in a bracket. So depending on the calculator, sometimes you have to, not negative 5, you got to put that negative 2 in a bracket up here. Okay, and some of them you don't. So it depends on your calculator. So I'll hit enter. Now the answer is 1. So you're going to have to try this on your own because every calculator is slightly different. Then we got 4 times 2 to the power of negative 1. 2. Okay, let's do the next one. 4 times 2 to the power of 0. Oh, that one's 4. Let's do the next one. 4 times 2 to the power of 1. 8. So let's put that in. 8. Okay, I'm going to put 8. Can you guess the next one? 1, 2, 4, 8. I bet you the next one's 16. So they just go double. 1 double is 2. Double that is 4. Double that is 8. Double that is 16. Double that is 32. Okay, we've got our numbers in a table. Now we're going to go graph. So we're going to go to the graph. I'm going to graph these numbers. Okay, I'm going to switch over. Okay, switch to the graph. Let's go down here. And I'll switch to this graph, and I'll do this one in red. So at -3, we're at 0.5. So it's like halfway. So it's, see if I can put that dot halfway between the lines. So see my first dot. Okay, at -2, we're at 1. So we put a dot at 1. Okay, at -1. Okay, we're at 2. It's kind of tricky. At 0, we go to 4. Okay, at 1, we jump all the way to 8. Okay, at 1, we jump to 8. At 2, we jump to, we can still fit it all the way up to 16. So a dot goes up there. And it's very hard for me to put these dots with this marker I have that works on the board. You guys can probably do a better job than me. Okay, they fit like that. And then you put a curve through it. So the curve should look like, it should go right up like that. It should come down here, and it should steeply go up like that through those points. So there's our first curve. Okay, and I'm sure you guys can do a little bit better job than what I just did there. I'm going to pause the video, and then we're going to do the second graph.